Today we're going to talk about some conditions for a unique triangle. And in particular, we're looking at 3 sides and 2 sides and the included angle. Your objective today, I will demonstrate my mathematical ability to validate that 2 triangles are identical if corresponding sides and the included angle are equal under some conditions, or under some correspondence. 2 sides and the included angle of a triangle determine a unique triangle through class discussion. Let's go ahead and get started. Okay, this first problem is just going to serve as a review for how we can use a compass to help us out with this problem. Okay, first off, I want to make a triangle, and I've just given you the sides, and basically all we're doing is drawing the same triangle, just in a different condition, because I just gave you the sides. So first off, okay, if I label this line, this is going to be X and Z. Okay, now I'm going to use my compass again, bring it back out here. Alright, and I'm going to, Z is going to be the radius or the center point of my triangle. Bring this out, okay, and I'm going to draw my circle. Okay, now I'm going to come back up here and measure my other side. Bring this back because X is going to be my radius or my center point of my new circle. Draw this out to where Y is supposed to be. Eventually, there we go. Okay, bring this back over to here. Alright, and now I'm going to draw my second circle. And then I can draw my lines. Okay, I'm just going to draw my line, get my line tool, because I'm going to start right here. Actually, no, I'm not, because that wasn't right there at the point. Okay, so I'm going to go this way. Okay, I'm going to take that same point and come down to X. Alright, and then this shows that there again, just as a review on how to set all this up. I could go through and erase all the circle and construction work, but it says leave all construction marks in evidence. Now I need to label the new triangle. Okay, so this would be X prime, Z prime, and Y prime. The exact same measurements and angles are all right here. Alright, let's go ahead and look on how this is going to take a factor in what we're talking about today. Alright, so in this problem we're going to redraw this triangle because I want to make a copy of it. However, I don't know what the measurements are for the angles. I could get a protractor out and do it. Sometimes that's rather hard to do it that way, but you could. Alright, I'm going to keep in what I'm doing and looking at a compass. So this is going to be B prime and C prime. Okay, so let's go ahead and get our compass back out. Alright, now I want to, C is my radius, and then B is the outside of the circle. Draw my circle. Okay, it's okay this went off the screen a little bit because that's not the side I'm using. Alright, now I want to figure out what B and A are. So B is going to be, or actually A is going to be the radius of my circle. No, B is, sorry. It's a step differently than I normally have it set up. Alright, and I'm going to bring my compass out. I'm going to go back and reset this at point B, or at vertex B. Alright, draw my second circle, if it'll cooperate. Alright, and then I'm going to get my lines back out. and connect everything. Okay, I need to redo that line. Alright, so then this is the exact same triangle. So that would mean that this, let me get my lines back out. This would be congruent, this would be congruent, and then this would be congruent, and this is A prime. Okay. Now if I were to go and measure these, the angles would be are 40 degrees. This one's 40 degrees. This one's 33. And that would leave this angle here at 107. Okay. And then I could go through and I can measure the angle measurements as well. There again, all I now know is I have the 3 sides and I can do it. Now let's look at if I have 2 sides and the included angle. Alright, so this is going to be point D prime. Now, I want to get my compass back out because that's kind of what we've been working on with a little bit. Okay, stick this right at the end of D. Okay, use my compass. Alright, now I'm going to bring that up. There's that angle. Okay, so this point right here is my D. No, is my E rather. Okay, because we already know where point D's at. This is point E right here. Now let's do the same thing. Let's change the circle, the line a little bit. Okay, we're going to do the exact same thing to figure out how far out. Nope, that's not it. Okay. Raise that up a little bit. Okay. And make my circle. Okay. So that means that I need to extend my line out. Okay. So my line now, start right here, is going to go way out to this point. Okay, to the edge of the circle. And then it's going to come back up to this point. And there again, I would label my triangle. Okay. Because I know my included angle is 40 degrees. Okay. I know that this is going to be 33 degrees. And then this is going to be 107 degrees. Okay. If I was to measure all these out, I know that this one's 7 centimeters. This is 4 centimeters. If I was to bring my ruler out, I would get that this is 4.4 centimeters. No, 4.7. Okay. So I could actually, if you wanted to, you could just measure these out. Measure out from this point here 4 centimeters. Measure out this point here 7 centimeters, and then connect them. That's another way you could do it too. Alright, but we're trying to use, the more we can use some of these tools, the better, the closer we're going to get. And I don't care which way you do it. Alright, let's look at another problem. Okay, I'm going to do this one a little different. I'm going to start out with my line. So I'm going to get my line tool up here. Okay. I'm just going to extend it out way far, because that's where I want to start with. Alright, I'm going to bring my protractor out. And the reason I'm going to do that, because if I read it, it says angle XYZ has a side length of XY is 2.5 centimeters, XZ is 4 centimeters, and the angle X is 120 degrees. Draw the triangle under this exact same conditions. So I'm going to use my protractor this time, because I want to show you how you can do it without all your compass and all that business there. So I'm going to take this and I'm going to take my measurement to 120 degrees. Okay, I'm going to draw my second line. All the way down so it connects. Alright, I'm going to redraw it because it wasn't right. Alright, so now I need to figure out my distance here. Okay, so I'm going to get my ruler now and I'm going to do some measurements. So I know, before I get started, I know that this is going to be X. Oh, I don't like that color at all. Let's get another color that we can see. We'll go with pink. Okay, so I know that this point right here is X. Alright, so X, Y, and because this is not as long, that's how I'm going to do it. XY is 2.5 centimeters. So I'm going to put my ruler here, bring it all the way around, okay, because I want to measure just 2.5 centimeters. Okay. And I'm going to draw a line at 2.5 centimeters. Alright, so there's my line at 2.5 centimeters. Now it says XZ is 4 centimeters. So I'm going to rotate my ruler back around. Okay, so I can measure my 4 centimeters. Bring this up here. I'm going to draw my line to 4 centimeters. And then I'm going to bring this back around and connect my two lines. And there is my triangle. I use a protractor this time instead of a compass, and I was able to measure my angles out. Now I know this is 120, right? If I was to measure these out, this would be 23 degrees, and this would be 37. I already had this written down, that's how I know that. Okay, that's X prime, Z prime, and Y prime. Alright, this is 4 centimeters. This is 2.5 centimeters. Let me rewrite that. 2.5 centimeters. And then this is 5.7 centimeters. Okay, I don't care which method you use. You could use the method that we talked about on the last one where we did all the circle business, or you could just measure this out. I really have no preference as long as you can draw the triangles in the particular conditions that are given. Okay, and on your assignment you're going to hear a little bit about the diagonal. Okay, so I really want to talk about real quick, what is a diagonal? If I give you a rectangle like we have here, okay, the diagonal is simply, going from point, there's two diagonals here. There's point A, or line AC is a diagonal. Okay, they're diagonally across from each other, and line BC are the diagonals. Okay, a triangle is simply half of a rectangle more than likely. Okay, or a part of a rectangle. Okay, especially if it's a right triangle. If I was to draw the other side of it, it would make a rectangle. So a diagonal is just simply the longer part, the longer side usually of the triangle is the diagonal, because I can split this side here, so this could be one triangle and this could be another triangle, and I'm splitting that based on the diagonal there. I could have done it the same way this way as well. Alright, see you in class.